what's the domain of definition of a function of several variables, and how to find the domain of definition of a function of several variables? First, the domain of definition is, as you might know, the set of allowed values. It's the set of all the values that can be used as variables, as input variables for a function of several variables. So if your function is a function of two variables, the set of allowed values is a set that belongs to R2. All the values that can be used as input variables are points in R2. If your function is a function of three variables, then the set of allowed values is a set of values that belongs to R3. Now, how to find the domain of definition? To find the domain of definition, we should find the set of these allowed values. Let's take an example. So if we take a function f of xy that is equal to 2x ln of x over x plus y minus 1 plus square root of x2 minus y. So the first step you should do to solve such an exercise is to write we should have, so you explain what you are doing, so we should have, what's the condition that you should have. So then afterwards you should cite all the conditions that should be satisfied for this function to be defined. So what are the values that can be used as input variables? They are the values that can be used inside this function. So they are the values that can be used inside the ln. They are the values that they can be used with the square root or in the denominator. Usually these are the most common conditions you might have. So something inside the logarithm, something with a square root, or in a denominator. And usually, or all the time, whatever you have in the denominator should be different than 0. Whatever you have with a square root should be greater or equal to 0. And whatever you have inside an ln should be greater strictly than 0. So you should have, and then you cite the conditions. X strictly greater than 0, x plus y minus 1 different than 0, and x2 minus y greater or equal to 0. Then, in the next step, you will try to modify each one of these conditions so you can interpret graphically what they will mean. So let's take x greater than 0. That's all the points that have their abscissa greater strictly than 0. If you take x plus y minus 1 not equal to 0, this means that y is not equal to minus x plus 1. That's nothing but the equation of a straight line. But we are not saying that y is equal to minus x plus 1, so y is not equal to minus x plus 1, which means that the points should not be on this straight line, but elsewhere. And for the final condition, x2 minus y greater than 0, it can be written as y less or equal to x2. So somehow it's the equation of a parabola. So what you need to know to solve such an exercise is to know, of course, these types of equations. What you might encounter are equations of straight lines, equations of parabolas, equations of hyperbolas, maybe like y greater than 1 over x, or also equations of circles or ellipses. So these equations, you might have them when you are solving such an exercise. So let's try to interpret graphically what these equations or these conditions mean. X strictly greater than 0 means that the points that are allowed are only the points that have their abscissa strictly positive. So we should remove the y-axis and all the region where the points have their abscissa negative. Then in the second condition, we have y not equal to minus x plus 1. So let's try to draw the line y equals minus x plus 1. Let's take 2 points. If x is 0, y is 1. If y is 0, x is 1. So let's try to sketch this straight line. It's this purple line going through these 2 points. And since y should not be equal to minus x plus 1, then we should remove this straight line from our domain. Finally, we need to sketch the parabola y equals x2. But y should be less than x2. So we need to determine the region where y is less or equal than x2. We take 1 point. Let's say this point here. That's the point minus 1, 0. So if we put minus 1, 0 instead of x and y, we will have 0 less or equal than 1. So this is the good region. This is the region that satisfies the inequality. So the region inside the parabola is the region that we don't want. So we need to remove this region. So the domain of definition will be the region that is left. So it will be this part in here, together with the parabola because the inequality is not strict, but deprived of the straight line, y equals minus x plus 1. And between the straight line as well in here, and the y-axis, but deprived as well of the y-axis. And we are always below the parabola.